Hey guys, Miss Gosling here. In this video, we're going to talk about circular motion and fields, specifically electrostatic fields. By the end of the video, you'll be able to synthesize what you know about circular motion and electricity, and I suppose gravity as well, but we've already done that. Just like gravity, the electrostatic force can act as a centripetal force. It can keep objects moving in a circle. The best example of the electrostatic force acting as a centripetal force is in the atom. So as you guys hopefully learned in chemistry, the electrons in an atom orbit around the nucleus of the atom where the protons all live. This is very similar to the fact that the Earth rotates around the sun. The electrostatic force is the primary force responsible for the electron's orbit around that central nucleus. So let's go ahead and take a look at an example. The distance between the nucleus of a hydrogen atom and its innermost electron, known as the Bohr radius, is 5.29 times 10 to the negative 11th meters. How fast is the electron traveling? Now, a couple of things that you guys need to know to be able to solve this problem. First, you need to remember that hydrogen has one proton and one electron. So the charge of its nucleus is plus 1e, and of course the charge of the electron is negative 1 times the elementary charge. Because the electron is orbiting, so that is my object that is in circular motion, we also need to know the mass of the electron from the data booklet, which again is still 9.110 times 10 to the negative 31st kilograms. So with that, let's go ahead and get started. So my givens and my unknown, I know that the charge of the hydrogen atom's nucleus is equal to the charge of its innermost electron, which is equal to the elementary charge. And again, we're just going to look at the magnitudes here because we know that we already know the direction is centripetally. It is attractive because these are two unlike charges. So that means that the charge of each of both the nucleus and the electron is the elementary charge, or 1.602 times 10 to the negative 19th coulombs. I also know that the distance between those two objects is 5.29 times 10 to the negative 11th meters, and that the mass of the electron is 9.110 times 10 to the negative 31st kilograms. That brings me to my equation, and my substitution, and eventually my solution. So I know that the electrostatic force in this scenario is acting as a centripetal force, because I know that the electron is orbiting around the nucleus. Therefore, I know that K times the charge of the nucleus times the charge of the electron divided by the distance between them squared is equal to the mass of the electron times its speed squared divided by the radius of its orbit. Solving for V, I get that V is equal to K times Q divided by R times the mass of the electron. And of course, we need to take the square root of that whole big ugly thing. If you don't trust me on the algebra, or if you want to go over the algebra with me, please feel free to ask me about that in class. But I'm going to go ahead and go straight into plugging in my numbers. So K is 8.99 times 10 to the 9th. Q1 and Q2 are both 1.602 times 10 to the negative 19th coulombs. So I'm just going to square that number. The distance between my electron and the nucleus is 5.29 times 10 to the negative 11 meters. And we're going to go ahead and multiply that by the mass of the electron, 9.11 times 10 to the negative 31st kilograms. And of course, after the very end, I'm going to take the square root of everything. When I put this in my calculator, I get that the speed of the electron is 2.19 times 10 to the 6th meters per second. Now, one thing I want to point out that you may have noticed is that I completely ignored the existence of any potential neutrons in the hydrogen atom. The reason for that is that when we talk about the electrostatic force, we only care about things that have a charge. So if something is neutral, like a neutron, if it has no charge, then that means that it is absolutely irrelevant to my calculations of the electrostatic force. So with that, let's go ahead and discuss takeaways. First of all, it's important to know that electricity can be a centripetal force, and that electron orbitals are an excellent example of electricity acting as a centripetal force. So there you have it, guys. You have now learned about how electricity can make things move in circular motion. Now it is your turn to solve some more challenging questions on your own. Best of luck and happy solving!